Hello, my name is Marcus Sidlmeier, and this is my biomechanical analysis for XNB 272 Biomechanics Assessment 3. The long jump is a popular athletic sport that's been part of the Olympics since its very beginning back in 1896. The main goal of the long jump is to achieve the longest possible jump from a designated starting point without descending backwards after the landing. By using a deterministic model, we can decide what factors need to be observed to achieve the largest jumping distance without descending backwards. This is achieved by increasing momentum and then transferring it forward. This is achieved through the creation of vertical impulse. Vertical impulse can be increased by knee, hip, and ankle extension after the takeoff, also by lowering the jumper's center of mass by increasing the stride length just before the takeoff, and also by releasing stored energy through knee flexion. Increasing vertical velocity is also important. This is done by increasing the takeoff angle to ensure a longer flight time, and by increasing the run-up speed. Once these variables create momentum, it is transferred forward through shoulder rotation and hip extension. Once the jumper lands, torque needs to be reduced as well. This is done by landing heel first and also by increasing shoulder extension. The jump was observed using a side angle shot throughout the entire movement. This allowed for the analysis of the knee joints, as they are plane-synovial joints that only move along one sagittal plane. The side view also allowed for a clear analysis of the jump angle, which is a very important feature for this jump. The shot was filmed on a 1.5 meter tripod to incorporate the entire body, including both the upper and bottom appendages. The surrounding areas were dimmed and a light source was shined directly at the jumper to allow for a clear and comprehensible recording. The recording tool was calibrated to record no less than 100 frames per second to allow for a very detailed recording. The analysis of the jump will now begin. We'll begin with the takeoff, followed by the flight, followed by the landing, and correcting the movement along the way. The first stage during the long jump is the takeoff. The most important variables during this part is the knee flexion angle during the jump and the takeoff angle. The knee acts as an energy absorber, which releases the stored energy to generate momentum and transfers this momentum onto the rest of the body. The angle of flexion of the knee joint is what influences the amount of momentum generated. If the angle is too small, the energy cannot be transferred to the rest of the body. In comparison, if the angle is too large, not enough energy is released during knee extension, which could in turn decrease the amount of momentum generated. In this example, the jumper was outside of the ideal knee flexion range of 163 to 169 degrees. In order to maximize the amount of momentum generated and released, the jumper in this example would have to move their hip from point 1 to point 2. This would increase the knee flexion angle to be within the ideal range. When this happens, more energy can be stored and released in the form of higher momentum, which would in turn increase the total jumping distance of this person. In order to achieve the most ideal flight path and to maximize horizontal velocity, the takeoff angle should be closest to 22 degrees. This angle allows for the highest amount of horizontal displacement while still efficiently increasing the vertical velocity as well. This is also important, and this will be discussed later. By using the jumper's center of mass, the angle could be calculated to be 38.4 degrees. This is too high because it decreases the amount of horizontal velocity achieved, while too greatly increasing the vertical velocity. The jumper should decrease the takeoff angle to be closer to 22 degrees instead. This would allow for higher horizontal displacement. The second stage of the long jump is the flight phase. The most important variables during this phase is shoulder flexion and leg positioning relative to the flight curve. After the takeoff, the generated momentum needs to be transferred forward. This is achieved through shoulder flexion and rotation. This is done by circling one's arms back over one's head and then back towards their hips from the front. This allows the momentum to be transferred forward to achieve more jumping distance. In this scenario, the jumper did this perfectly, and there is nothing to correct in this aspect. During the flight phase, the jumper needs to keep the legs and feet at or above the flight curve. This is to increase momentum by transferring the weight forward. By moving the jumper's center of mass forward, vertical velocity is increased because the weight of the person is situated in front of the jumper. This also prepares the jumper for the heel landing, which will be talked about during the landing phase. Figure 1 represents the correct leg positioning relative to the flight curve. Represented in Figure 2 is the jumper and their leg positioning. The legs are clearly below the flight curve, which is represented in green. This would transfer the weight downwards, which would also decrease the amount of momentum that is being transferred vertically, where it's supposed to be. The jumper should move their legs from positions A to leg positions B, which are represented in orange. This would keep the legs above the flight curve, which would increase the amount of momentum that is being transferred to the front. The third and final stage of the long jump is the landing. The important variables for this part is hip extension, foot positioning, and shoulder flexion. A higher flight time will also increase the vertical velocity. A higher flight time can be achieved by tilting the pelvis forward or flexing the hip joint. This will move the legs up, which will increase the flight time as it delays the touchdown. In Figure 3, this is represented using a drawing. Figure 4 represents the jumper. The jumper's hip joint was not properly flexed during the final stages of the flight. This means that the amount of flight time was reduced, which therefore reduced also the vertical velocity. To correct this, the jumper's pelvis should tilt forward in the direction of the green arrow by flexing the hip joint. This would move the jumper's feet from point A to point B, which is represented in the photo. This would increase the amount of flight time achieved, which would also increase the vertical velocity. Torque is a major problem for long jumpers. During the flight phase, the long jumper's body will rotate either clockwise or anti-clockwise. However, the opposite will occur when the jumper lands. This is the result of torque. This results in them usually descending backwards, which will decrease the total amount of jumping distance achieved for that jump. To counter this, the jumper must land heel first and then swing their arms forward and then slowly make contact with the rest of the foot in a forwards motion. So ideally, the jumper would land heel first and then slowly move the weight forward in one smooth and consistent motion. When analyzing this video, it was noticed that the initial point of impact for the left foot was the heel. However, for the right foot, it was the forefoot. Since the forefoot created first contact with the ground, the ankle rolled backwards, which means that torque was not compensated for in that foot. To correct this, the jumper must make sure that they land heel first and then move their weight onto the forefoot. This will compensate for any torque and will make sure that the jumper does not descend backwards after the landing. Another way to reduce torque during the landing is by flexing the shoulders by moving them backwards. The jumper did this perfectly and there is nothing else to correct. Overall, the jumper presented an average technique during the long jump. However, a lot of factors would still need to be corrected to increase the jump's efficiency and to prevent injury. Thank you for listening to my analysis of the long jump and have a good day.